Detail comparison. A-18E, F Super Hornet vs Dassault Rafale M. Rafale and F-18 are the world's most known fighter jets, and if you are someone who is into aviation, then there is no way you have not heard about these two bad boys. Let's talk about these two. French Rafale M and Boeing A-18E, F Super Hornet entered service less than 1,000 days apart. It is hard to find a fast jet capable of operating in the harsh conditions of an aircraft carrier. These two fighter bombers are an example of that uncommon breed. One is the centerpiece of the U.S. Naval Aviation Force, built by the world's largest aeronautical business, while the other is proudly independent France's first real carrier fighter. Let's see how they compare. This article will compare A-18E Super Hornet Block II and an F-3R standard Rafale M. The Rafale M versus the Super Hornet. The primary sensor on both the Block II Super Hornet and the F-3R standard Rafale M is an active electronically scanned array, AESA, radar. The APG-79 version of AESA radar is fitted to the Super Hornet Block II. In contrast, the RBE-2A version of AESA is provided to the F-3R standard Rafale M. These radars can simultaneously scan and track air functions on sea and ground targets. It's interesting to note that the nose apertures of the Rafale and the Super Hornet are both similarly narrow. Compared to AESA-equipped fighters with wider noses, such as the F-15 and F-22, this limits the number of transmit and receive (TR) modules that can be put in a fixed radar array and make options to improve scan width, such as rotating mountings. However, both types achieve the milestone of fielding an operational AESA radar before many rival designs. Detailed performance numbers for AESA radars are closely guarded. However, we do know that the Rafale's RBE-2A can conduct a more simultaneous scan and track operations while having a slightly shorter maximum range than the Super Hornet's APG-79. The dedicated Department of Test and Evaluation, DOT&E, and the U.S. Navy's Operational Test and Evaluation Force have given the APG-79 unsatisfactory assessment reports. APG-79 was introduced in late 2010, and since then, it has faced numerous reliability and working problems. Built-in options for electronic attacks have been put off over and over again. Competitor evaluation and mission analysis in the early 2010s revealed that the APG-79 and mechanically scanned radar-equipped Super Hornets performed similarly in mission effectiveness. Dassault has well-integrated Rafale's mission systems and sensors. Land-based Rafale combat testing with identical radar and software fit was successful over Iraq and Syria. As a result, the Rafale M and F-3R configuration arguably has a better radar than the Block II Super Hornet in most multi-role circumstances. Acceleration, climb rate, top speed, ceiling. Despite being deemed underpowered compared to dedicated air superiority fighters like the F-15, Typhoon, Su-35, and F-22, the Rafale M easily defeats the Super Hornet in all these categories. Su-35 and F-22, F-15, Typhoon and Su-35. Range, endurance. Combat aircraft have a very variable range since a lot depends on the weapons and other supplies they carry, the external fuel tanks they carry, the mission profile they fly, the amount of time they need to be on station at their destination, and the amount of reserve fuel they have for getting back to the deck or making a change. The Rafale M and the Super Hornet can refuel in the air using a probe and drogue-equipped tankers. This is called buddy-buddy refueling. However, the Rafale M has a substantially broader overall combat radius for most missions than the A-18E because of its significantly greater cargo capacity, less draggy airframe, and ability to fly higher and faster, notably in dry power. Weapons options. In terms of weaponry, the Super Hornet is in the lead on most fronts. Super Hornets can carry and deliver nearly every weapon in the United States air-launched arsenal. In contrast, the Rafale M can carry a substantially larger external payload, especially when equipped with 3 external fuel tanks. Conversely, on the other hand, Rafale M uses the excellent but costly AASM Hammer series of guided bombs. There is a dual-mode laser, GPS, INS guided, and infrared, IR, guided versions, as well as kits with a rocket booster motor that lets you shoot farther. Also, it is approved to receive the Paveway 2-3 series of laser-guided bombs, which can be used for aggressive attacks at a reduced cost. Conclusions. For Super Hornet. The most significant advantage of the Super Hornet is that it has a large user base, so spare parts and upgrades are cheap. It is also easy to control, has excellent high-alpha performance in a merger, and can use all U.S. air-delivered weapons. While the biggest drawback is that it doesn't have enough power for its weight, especially at high altitudes, and the way its pylons are set up makes the drag of its external stores worse. For Rafale M. Most significant advantage. Aerodynamics and electronics are at least half a generation ahead of the Super Hornet, and the WVR performance below 35,000 feet is brutal. And the drawback with it is that the small number of users and French-made weapons and systems means that operating costs are higher, and the global supply of spare parts is much smaller. Also, they still don't have an HMS. Thanks for watching.